Now let's go to some simple problems on linear motion. First of all, let's look at the meaning of the slope of a velocity time graph. Now, given any 2 points on the slope of a velocity time graph like this, these 2 points, we have coordinates T1 and what? T2. They will have coordinates T1 and T2. They will also have coordinates, let me change this. They will also have coordinates U and what? U is like V1, initial velocity, and V, which is like V2, final velocity. So if we need the slope of, this curve between these 2 points, if we need the slope of the velocity time graph between those 2 points, all we need to do is, find the slope of this triangle. So the slope of this triangle will be what? Delta. Find the slope along this triangle will be delta y, which is also the same thing as change in velocity over change in time. Now, change in velocity here, change in velocity is what? Change in velocity over time is change in velocity per unit time. And that's the same thing as acceleration, which is v minus u over t2 minus t1. So that means that the slope of a velocity time graph is the same thing as the acceleration of the motion. I hope you can see that here. The slope of a velocity time graph represents the acceleration of the motion. Let's now take the questions one by one. The first question here says, a boy cycles continuously through a distance of 1 kilometer in 5 seconds. Calculate its velocity. Now, 1 kilometer in 5 seconds. That's very easy. Distance traveled S is 1 kilometer. Time taken is 5 seconds. First of all, we cannot manipulate kilometer and seconds. We have to change this distance to meter. 1 kilometer is the same thing as 1,000 meter, which is 100 meter, and 5 seconds. Average velocity. Average velocity is distance traveled over what? Over time taken. So that's 1,000 meter over what? 5 seconds. 1,000 meter over 5 seconds is, I want to be sure I'm not, okay, not 5 seconds. The time is also not in the SI unit. The time is 5 minutes. So I have to do some conversion on the time, 5 minutes. Let me correct that here. Time is 5 minutes. Also, minute is not the SI unit of time, so I change it to seconds by multiplying it by 60. That gives me 1,000 meters over 300 seconds. That's what? 10 over 3 meters per second. And that's 3.33 meters per second. Is that clear? So, take note. Let's go to the second question. Number 2 says, let's go to question 2. Question 2 says, an aircraft jet flying with a speed of 335 meters per second went past an aircraft gun. How far is the aircraft 5 seconds later when the gun was fired? Okay, here we have the distance. Okay, how far means distance. How far? How far means we are looking for distance. So you write S question mark. We have the velocity, 335 meters per second, and you have the time, 5 seconds. So from the formula, average velocity, average velocity is distance over time. If you cross multiply, 1 times S is S, S is VT. So that means your distance traveled is 335 meters per second times 5 seconds. So cross S will divide S, you get 335 times 5, and that will give you your answer. So the distance traveled is 335 times 5 in meters. You get your answer in meters. That's the answer to question 2. Let's go to the next question here. Number 3 says a car travels with a constant velocity of 45 kilometers per hour for 20 seconds. What distance does it cover in this time? 45 kilometers per hour for 20 seconds. Let's be fast. Number 4. Or is it 3? Excuse me. Let me check. Okay, it should be question 3. I'll have to clean this. Sorry about that. Number 3. Okay. Average speed, 45 kilometers per hour. Time taken, 20 seconds. What distance does it travel? So S question mark. We don't have the distance, so we represent it with what? S. Put a question mark. So what does that give us? First of all, my speed is in kilometers per hour, 45 kilometers per hour. It cannot be manipulated with time, which is in seconds. So I need to change this from kilometers per hour to meters per second. How do you change kilometer to meter? Times 1,000. How do you change 1 hour? 1 hour here is 60 times 60, which is what? 60 times 60. 1 hour contains 60 minutes. Each one contains 60 seconds. So that means 1 hour is 3,600 seconds. Also, 1 kilometer is what? 1,000 meters. So I'm changing my, speed from kilometers per hour to meters per second by multiplying it by what? By multiplying it by what? By 5/18. What does that give me? 9 here 2, 9 here 5. That gives me 25/2 meters per second. So I've changed this speed from kilometers per hour to what? Meters per second, like that. So I can now manipulate it with time, which is in seconds. Let's go. So I know my distance traveled is average velocity times time. So that will be 25/2 meters per second times 20 seconds. This is simple. Seconds will cross seconds. What do I get? 25/2 meters times 20. That will give you your distance in meters. You should, be the one to finalize these things yourself. Let's go to question 4. In question 4, it says a body starts from rest and accelerates uniformly at 5 meters per second square until it attains a velocity of 25 meters per second. Calculate the time taken to attain this velocity. Let's go. I need a velocity time graph for that. Not compulsorily, but, just to add to our knowledge. So, a body starts from rest. Time in seconds, that's the axis for time. This is the axis for velocity in meters per second. A body starts from rest and accelerates uniformly. At the acceleration is what? The rate of acceleration is 5 meters per second square. That's the gradient of that line. So I can write it on it like that. For what? It accelerated for 5 seconds until it attains a velocity of 25 meters per second. So this velocity is 25 meters per second. This time is 5 seconds. It took it 5 seconds to speed up from 0 meters per second to what? 25 meters per second. So my initial velocity is rest. Or let me say, rest means that accelerating from rest means that the initial velocity is 0 meters per second. The final velocity attained is 25 meters per second. The time taken to do that is 5 seconds. I need the acceleration. That's a simple question. I'll go back to my equations of motion. Which of the equations of motion which of the 4 equations of motion connects what? U, V, A, and T. That's equation 1. It is equation 1 that connects U, V, A, and T. So I'll say using V is equal to U plus AT. V is 25, U is 0, A is 5, but I don't know T. So 25 is equal to what? 5t. 5t is equal to 25. T is equal to 25 over 5. It will take it how many seconds? It will take it 5 seconds to accelerate to 25 meters per second. Oh, sorry, I didn't have this. That was what I was looking for. I didn't have this 5 seconds. The question was, a body accelerates uniformly from rest at a rate of, a body moves from rest with an acceleration of 5 meters per second square until it attains a velocity of 25 meters per second. Calculate the time taken. This time was to be calculated. So that's what I just did. I've made many mistakes here. I'm sorry about this. So I don't have time. I have my acceleration 5 meters per second square. So I'm sorry about that. Number 5. Let's go to question 5. Question 5 says, a train has an initial velocity of 44 meters per second squared and an acceleration of minus 4 meters per second squared. Its velocity after 10 seconds is, okay? So a train has an initial velocity. Let me write like this. I think it was the graph that confused my solution the other time. The initial velocity of the train was 44. So I've penned that down. The acceleration, it has an acceleration of minus 4 meters per second squared. And, it decelerated to what? To 4 meters per second. Let's check that again. Until it slowed down. It said its velocity after 10 seconds is, okay, so I have acceleration, I have initial velocity, I need its velocity after 10 seconds. So its velocity after 10 seconds, I don't know it, but I know the time as what? 10 seconds. So this is question 5. A train moving at 44 meters per second has an acceleration of minus 4 meters per second squared. This negative means that the train is slowing down. It's not speeding up. Its velocity is reducing. So you will see that when I draw the graph. After 10, what will be its velocity after 10 seconds? What will be its velocity after 10 seconds? Let's go ahead and do that. First of all, let me draw a graph that helps us see the motion in one piece. Time in seconds. Velocity in meters per second. So the train's initial velocity was what? 44. So after 10 seconds, what will be its velocity after 10 seconds? So let 10 be there. Definitely, one thing I know for sure is that it's going to slow down. The train will slow down. It's not going to increase in velocity. Its velocity will decrease. So it will slow down. That means the value I'm looking for is right here. I'm looking for the value of the velocity after 10 seconds. This will be my U. My U is what? 44, the initial velocity. I'm now looking for V. Final velocity, V is final velocity after 4 seconds. After 10 seconds, I mean. So let's go ahead and do that. What formula connects? First thing you need to think of is, what formula connects U, A, V, and T? What formula? Among the 4 equations of linear motion, which one connects U, A, V, and T? I think we have our answer. Using V is equal to U plus AT. The one that connects U, A, V, and T is V is equal to U plus AT. So in this case now, I don't have V, but I have U as 44, plus I have A as minus 4, and T as 10. This will give me 44 plus minus 40. That gives me what? 44 minus 40. So, what does that tell you? The final velocity after 10 seconds will be what? 4 meters per second. So take note of that too. Let's go to question 5. Let's go to question 5. question 6 now. Let's go to question 6. If a car starts from rest and moves with a uniform acceleration of 10 meters per second squared for 10 seconds, the distance it covers in the last 1 second is what? That's a very simple question too. A car starts from rest, so initial velocity 0 meters per second, acceleration 10 meters per second squared, distance covered in the last second, distance covered in the last second. If it travels for 10 seconds, if it travels from 0 second to what? 10 seconds. That means if you need the distance traveled in the 9th second, which is here, if you need the distance traveled in the 10th second, you will have to find the total distance. The distance traveled in the last second will be the distance traveled for all the 10 seconds minus the distance traveled for 9 seconds. Do you understand? So let's get distance traveled in 10 seconds. Using S is ut plus half at squared. We will get the distance traveled in 10 seconds using S is ut plus half at squared. In this case, the distance, when calculating the distance traveled for 10 seconds, our time will be what? 10 seconds. So let's go ahead and do that. That will be what? 0 times 10. Distance traveled for 10 seconds will be 0 times 10 plus 1 over 2 times 10 times what? 10 squared. That gives us what? 0 plus what? Let's just make this 0 disappear so we don't have to bother about it anymore. That's half times 10 times 100. This 0 has disappeared. 0 times 10 is 0. That gives what? 5 times 100, which is what? 500 meters. So in 10 seconds, it travels 500 meters. Also, let's find the distance traveled in 9 seconds. So using S is ut plus half at squared. Also, using S is equal to, I'm coming. Let me write the formula first. Using S is equal to ut plus half at squared. The distance traveled in 9 seconds will be equal to 0 times 9 plus, will be equal to what? 0 times 9. 0 times 9 plus half times 10 times 9 squared. That's what? 0 times 9 is 0. So this goes away. You understand? That will not be there anymore. You will be left with half times 10 times 9 squared is 81. What does that give you? What does that give you? That gives you what? 5 times what? 81. That gives you 5 times 81. And the distance traveled in 9 seconds is 405. So distance traveled in the last second. Distance traveled in the last second will be equal to S10 minus S9. Distance traveled in 9 seconds minus distance traveled in 10 seconds minus distance traveled in 9 seconds. That's 500 meters. That's what? That's equal to 500 meters minus 405 meters. And that's 95 meters. So in the last second, it travels 95 meters. Let's go ahead and do question 7. A body starts from rest and moves with uniform acceleration of 6 meters per second squared. What distance does it travel? What distance does it travel? What distance does it cover in the 3rd second? Starts from rest and moves with an acceleration of 6 meters per second squared. Okay, number 7 is similar to number 6. Okay, if something travels for 3 seconds, that means from 0, it goes from 0 second to 3 seconds. Let's say 1 second is here, 2 seconds is here. If you need the distance traveled in this 3rd second, which is the last second, all you have to do is very simple. Calculate the total distance. Calculate the total distance traveled for 3 seconds. Make this one S3. Distance traveled in 3 seconds. Also, calculate the distance it will travel for what? 2 seconds. Make this one S2. So the distance traveled in the last second or the third second will now be equal to the distance traveled in the third second will now be equal to distance traveled for 3 seconds minus distance traveled for 2 seconds. If it starts its initial velocity from 0. Initial velocity is 0 meters per second. Time taken is 3 seconds. You understand? When looking for S3, okay, let's do it like that. To find S3, remember, initial velocity is 0 meters per second. Time will be 3 seconds. S3 is distance traveled in 3 seconds. So initial velocity is 0. Time is 3 seconds. Acceleration is 6 meters per second squared. So S question mark. S is UT. The formula connecting U, A, S, and T. The formula connecting U, T, A, and S is the third equation of motion. S is UT plus half A T squared. S is UT plus half A T squared. That's what? 0 times 3, because we are looking for S3, plus half times what? A, which is 6, times what? T squared, which will now be 3 squared. So this side will go away. It will disappear. We have half times 6 times 9 left. That's 27 meters. The distance traveled in 3 seconds or for 3 seconds is what? 27 meters. In the same way, S2 will be equal to UT plus half AT squared, which gives 0 times 2. This is now calculating the distance traveled in 2 seconds. That's 0 times 2 plus half times 6 times 2 squared. What does that give you? That gives you 3 times 4. You know, from here, 2 here 1, 2 here 3. This one would have disappeared. So 3 times 4 is what? 12 meters. So S3, so distance traveled in the last, or distance traveled in the third second, which is the last second, which is the distance traveled in the last second, is S3 minus S2 will be equal to 27 meters minus 12 meters. 27 meters minus 12 meters gives you what? 15 meters. So in the last second, the train traveled 15 meters. Number 8, a body accelerates uniformly from rest at the rate of 3 meters per second square for 8 seconds. Calculate the distance covered by the body during the acceleration. That's a simple question. Let's go to question 8. A body accelerates uniformly from rest. The initial velocity is from rest, which is what? 0 meters per second. Acceleration is what? 3 meters per second squared. The acceleration occurred for a time of 8 seconds. So the question says we should find distance traveled. This is a simple question too. First of all, what formula connects U, A, S, and T? The formula connecting U, A, S, and T is the third equation of motion. So we say using S is UT plus half AT squared. S will be 0 times 8 plus what? Half times 3 times 8 squared. That gives you 0 plus half times 3 times 64. That's what? 0 will disappear. Our answer is 1 over 2 times 3 times 64. 1 over 2 times 3 times 64. 1 over 2 times 3 times 64. 2 in 64. 32. So that's 3 times 32. 3 times 32 is what? 96 meters. So the body will travel 96 meters. Take that as a first method. We could do it like this too. If we don't want to do it like that, we could also do it like this. Let's use another method. Let's say I draw the velocity time graph. If I draw the velocity time graph of that motion, the velocity time graph will look like this. Time in seconds, velocity in meters per second. The train or car or whatever accelerated from what? Accelerated from, from rest, which is 0 meters per second. For what? For how many seconds? For 8 seconds. It accelerated for 8 seconds. So, first thing you need to know here is that in a velocity time graph, the distance traveled is the area under the graph. The distance traveled is the what? Is the area under the graph. So if you want to find the distance traveled in this motion now, just do half base times height. One thing you should know is that this is already given. The acceleration is given as 3 meters per second squared. So I can calculate my velocity here. Let's say the final velocity attained after the acceleration is v. Let's assume the final velocity attained after the acceleration is what? V. So I can calculate v. If I calculate v, what will I get? Using v is u plus at. I know my acceleration as 3 meters per second squared. I know my time as 8 seconds. I know my initial velocity as 0 meters per second, but I don't know final velocity. So I can say I can go using v is equal to u plus at. What does that give me? Final velocity will be 0 plus acceleration 3 times 8. That's what? 0 plus 24. So the final velocity is what? The final velocity is what? 24 meters per second. Now, if I know my final velocity, I can get the area under the curve, because the distance traveled is the area under the what? The velocity time graph. And in this case, area is what? My area is half base times height, because my graph is a triangular graph. This is a triangular graph. This is a triangle with, height perpendicular to base. So what do? My height is what? 24. I've gotten this as 24. This height is the same thing as this v. Do you understand what I'm showing you? The height is the same thing as v. So my area is half base times height, which is half times the base is 8 seconds. The height is a velocity, 24 meters per second. That gives me 4 times 24 meters. Distance traveled is what? 96 meters. Can you see what I just did here? I used the area under the graph to calculate my distance, and sometimes you can use formula. Anyone you choose is correct. Let's go to the next question. Question 9 says, a particle starts from rest. We'll do it up to number 10 this time and take the next part in the next video. Let's just do it up to number 10. Question 9 says, a particle starts from rest and moves with a constant acceleration of 0.5 meters per second squared. Calculate the time taken by the particle to cover a distance of 25 meters. Okay, that's a simple question. Start from rest. Initial velocity is rest, 0 meters per second. Acceleration, it accelerates with an acceleration of 0.5 meters per second squared. The question says we should find the time taken to cover a distance of 25 meters. So if I was to draw a graph for this motion, my graph would look like this. Time in seconds, velocity in meters per second. It accelerated from rest and what? it accelerated from rest. We need the time taken. We need the time taken to cover a distance of 25 meters. We need the time taken to cover a distance of what? 25 meters. Let me use black. Distance covered, 25 meters. So, we know the acceleration. We know the acceleration. The acceleration is 0.5 meters per second squared. The acceleration stands as the gradient of this graph. So, we have marked the acceleration, everything is ready. So, here, I'll now decide what formula connects. This is S, A, U, and T. What equation of motion connects U, A, S, and T? Check your equations yourself. Which one connects U, A, S, and T? We just used this several times now. So, the one connecting U, A, S, and T is what? S is equal to UT plus half AT squared. So, my S is 25 meters. U is 0. T, I'm just looking for it. Plus half times 0.5 times T squared. I hope you are getting that. Let me make things more spacious. Let me make things more spacious here. Using S is UT plus half AT squared. I know my distance. The initial velocity is 0. Time, I don't have it. I'm just looking for it. Half times A, which is 0.5 meters per second squared, times T squared. So, we are getting there. That means 25 meters is what? 0 plus T. 0 times T is 0. That will disappear. I have half times 0.5 times T squared left. So, I can write this as 25 over 1 is equal to 0.5 T squared over 2 and cross multiply. When I cross multiply, what do I get? 0.5 T squared is 2 times what? 25. T squared is 2 times 25 over 0.5. T squared is 2 times 25 over 0.5. That means T squared is what? 50 over 0.5. 50 over 0.5 is 100. So T squared is 100. T is square root of 100. T is what? 10 seconds. So the time taken to travel 25 meters at this acceleration is what? 10 seconds. Let's go to the last question in this part. Question 10. Let's take it 10 at a time. So we'll do the next 10 in the next video. How far will a body move in 4 seconds if uniformly accelerated from rest at the rate of 2 meters per second squared? I hope you can see this well. How far will a body move in 4 seconds if uniformly accelerated from rest at the rate of what? At the rate of 2 meters per second squared. Let's go do that. So, acceleration 2 meters per second squared. Time 4 seconds. Distance we don't know. The acceleration came from rest, so the initial velocity was rest, 0 meters per second. How far will a body move in 4 seconds if uniformly accelerated from rest at 2 meters per second squared? First thing you need to check here, what formula connects A, S, U, and T? What equation of motion connects U, A, S, and T? We have used it many times. Using the formula connecting them is S is equal to UT plus half AT squared. So, in this case now, I'm looking for distance. My initial velocity is rest. Time is 4 seconds. Plus half times what? Half times 2. The acceleration is 2 meters per second squared. And my time is 4 seconds. That gives me what? Half times 2 times 16, because this one disappears, so it will not occur there anymore. All of this will go. I just have half times 2 times 4 squared to deal with. 4 squared is 16. My distance is 16 meters. So the body will travel 16 meters if uniformly accelerated at 2 meters per second squared for 4 seconds, moving from what? From rest. So I'm going to give you some exercises in the next video. Let's take a rest here.